Right, so to calculate B part 2, I actually swapped it around, B part 1 and part 2. To work out your kinetic energy, you literally just use the equation half mv squared. So once you, so you got your 7.9, so you can plug it back in and you can get your kinetic energy because you know your speed and you know your mass, so it's straightforward. Okay, so this is actually one method of doing it. There's another method of doing this as well, which is you can use Suva equations, because at position B, you know the speed is 0, and you know the height the gymnast travels from B to unstretched position is 3.2 meters, and you know the object is moving under gravity, so we say it's plus 9.8 meter per second squared, and the question is asking us to work out the speed at the unstretched position. So basically V, so you can do V squared is equal to U squared plus 2AS, and you can plug the numbers in to work out your V, which should turn out to be the same. So 2 times 0, you got 2 times 9.81 times your S is 3.2, so your V turns out to be, should be the same answer as before, 7.9 meter per second. Once you got your speed, you can plug that into your kinetic energy equation to work out your kinetic energy. Right, so let me quickly do part D. So for part D, the question is asking us to calculate the acceleration. Alright, so if let's do this quickly again. This is the unstretched position. Right, so they basically want us to work out the acceleration for the time period the gymnast is in contact with the trampoline. So basically from here to here. So once the gymnast lands on the trampoline, the trampoline is going to become depressed again. So it's going to go down to this position. And then when she's leaving the trampoline, we know the speed she's going to gain is going to be the speed we worked out earlier, which is 7.9 meter per second. So at the bottom of the gymnast, at the bottom of the trampoline, the speed is 0 meter per second. So to work out your acceleration, you do A is equal to V minus U divided by T, and they tell us in the question how long the gymnast is in contact with the trampoline, which is 0.26 seconds. So plugging these values into the equation, 7.9, take away your U is 0, over your time 0.2 seconds, should get your acceleration to be around 30.4 meters per second squared. So this is one way of doing it. Another way of doing it is, you know the distance the gymnast moves from here to here is 1 meters. So you can also use S is equal to UT plus half AT squared to calculate acceleration. Because how? You know your displacement, your U is going to be 0, acceleration is what you want to calculate, T is still, where did I write it? 0.2 seconds. So you can plug into the equation and work out your acceleration. You may be wondering, how do I get your displacement to be 1 meters? So, right, let's say from position, let me quickly explain that. From B to the bottom of the trampoline is 4.2 meters. From B to the unstretched position, it is 3.2 meters. So the displacement from here to here is 1 meter. And that's the 1 meter that's going to go in here. Hopefully that makes sense.